Okay, we have here today an interesting inverse Laplace transform I want to go over. We have here the inverse Laplace transform of s over s plus 4 squared. Okay, now the reason I like this one is you'll just notice that this is not quite like any formula we have in our Laplace transform table or anything we've went over so far. Now you'll notice this is almost similar to like if this was just 1 over s squared shifted, but the thing is we've got this s in the numerator, so we can't really work with it that way. So if we just had a constant value in the numerator, we could just shift it maybe and use this. But since that's not the case, we need to do something else. And what we can do is, I still can actually manipulate the numerator and get it so we can get some simplification. So I think it would be nice if we actually had s plus 4 here in the numerator, because then we'd have cancellation. Well, we can't just do that, but if I subtract 4, now we're adding 0. So doing it this way, I can actually split this up into two Laplace transforms. So let's see what we have if I rewrite this. So the first one will have s plus 4 over s plus 4 all squared. And for the second one, I think I'll just bring the minus 4 out front because I can bring a constant outside of the Laplace transform, even with the inverse. And so here we're going to have just 1 over s plus 4 squared. But now over here for this first one, we can cancel this with one of these. So I'll just rewrite this now with just a 1 in the numerator, 1 over s plus 4. And then let's just copy down all this other stuff. But now for this one here, I think we're all set because this is going to be just our formula for the Laplace transform of EAT. So let's just look at that formula really quick. If we have the Laplace of e to the AT, this is going to be just 1 over s minus a. So in this formula, if we have s equal to minus 4, plugging that in, minus times minus 4 gives us our s plus 4. So for the inverse, just reversing this and taking our f of t and plugging in the a, this first piece is going to be e to the minus 4t. Now here for the second one, we can actually use what I was trying to do the first time around. So let's just look back at a couple formulas we've used. We've done the Laplace of t to the n for an integer is going to be just n factorial over s to the n plus 1. So if we look at just the Laplace of just t, looking at our n value as 1, so we can write t as t to the 1. We end up here with 1 factorial, or just 1, over s squared. So the only thing is we don't have 1 over s squared here, we have 1 over s plus 4 squared here. But what we need to do is use our formula for shifting it. So we have this other formula that is Laplace of EAT times some function f of t is going to be the Laplace of that function shifted by a. So what I can do is take this Laplace of t, we can call this our f of s. Oh, not enough space. We'll call this our f of s, but then we just need to shift it. And the shift is going to be minus 4 in order to get this s plus 4. So let's just see if we had the Laplace of e to the minus 4t times just t. That's going to give me this thing shifted by a. So this is going to be the same thing as 1 over 6 plus 4 squared. So for the inverse Laplace, we just need to go backwards and use this. So putting it all together for the final solution, we're going to have e minus 4t minus 4, and then we're going to have this piece right here, just e minus 4t times t. So let's write the final solution with e minus 4t factored out times 1 minus 4t, and that's it. Okay, so there you have it. Good problem. More Laplace transforms to come in the next video. Thanks everyone for watching. Have a good day.